I'm Conrad De Peuter, and I'm joined by Shradha Ambekar. And today we will be discussing accelerating GenAI innovation, lessons learned from Intuit's reusable agents and tools framework. So I am a senior staff AI scientist at Intuit. I lead an AI R&D team, and Shradha is a senior staff engineer at Intuit, an open source contributor, and a member of our data org. We're joining you from Intuit. Intuit is a financial software company which serves small businesses, self-employed, and regular consumers. And for all of our customers, our goals are to get them more money, to have them do less work, and to have it all done with complete confidence. We do so through an AI-driven expert platform. Diving deeper into Intuit's platform, and to give you an idea of the scale at which we operate, Intuit has 87 million consumer customers across the US. Intuit also serves 10 million small businesses. On the financial side, we process $107 billion of refunds every year, and for most people, that's their biggest paycheck of the year. On the small business side, we process over $2 trillion of invoices every year. To operate at this scale, you need to have a platform mindset, and you need to have strong platform capabilities, and Intuit invests heavily in that. Today, we'll be diving deep into one component of Intuit's platform, GenOS. GenOS is a paved road for GenAI app development and agent development at Intuit. Now, I can only speak for Intuit, but GenAI came on very strong and very quickly. There was not much time between GenAI being a technology that just a few teams were poking around in to a significant focus of most engineering teams at Intuit. And that rapid scaling posed a lot of problems for Intuit. And to solve those problems, we built GenOS. And some of the motivations for building GenOS. Early on in the journey, let's say 2 to 3 years ago, there was a lack of enterprise-grade GenAI app development solutions supporting multiple vendors. While now we have Amazon, we have Azure, these things did not exist early on in the GenAI development process. And this was even before ChatGPT Enterprise existed, but those platforms lock you into a specific vendor. And we don't want to have vendor lock-in. Another motivation for building GenOS is just the critical importance of responsible AI in governments in our space. We deal with people's money. A hallucination can cost customer money. And we need to be extremely careful in everything we do, and we need to have responsible AI built into the fabric of our applications. We also have significant data governance controls and significant security controls. Many people try to use Intuit for fraud. They try to steal your refund, and we need to make sure our applications protect you against that. We also have a lot of different applications, different customer-facing applications, and we want to make sure we're reducing the duplication of common patterns across those applications. Those are the main focuses or motivations for building GenOS, and all of this is focused on the priority of keeping developers focused on solving customer problems. We don't want our developers to worry too much about data governance. We want them to be able to rapidly experiment and solve customer problems. We want them to be able to get to end-to-end production as quickly as possible and not have to focus on responsible AI. To give you an overview of GenOS's architecture, GenOS sits in between existing Intuit capabilities, such as the tax engine, such as the payroll engine, in between those and Intuit Assist, which is the customer-facing applications that you may see GenAI operate in through your product. So Intuit Assist appears in QuickBooks, it appears in TurboTax, MailChimp, Credit Karma, and our expert products. There are a few different components of GenOS, and I'll dive a bit deeper into each of those. One of them is GenStudio, which is a sandbox environment allowing developers to experiment with an extensive catalog of proprietary foundational Intuit LLMs. These are ones we train on our own, and commercial LLMs, such as GPT, Claude. Another component of GenOS is GenSRF, which stands for Security, Risk, and Fraud. These are built-in guardrails against threats such as prompt injection and data leakage, and these enhance the security and control of our AI agents. This is what makes sure our applications are responsible and protecting our customers. We also have GenUX, which is a library of front-end UI components that make sure all of our applications have a consistent look and feel across TurboTax, across QuickBooks, Credit Karma, et cetera. There's Gen Runtime, which is an intelligent layer that combines LLMs with data, knowledge, and grounding capabilities, such as customer data. And this operates at runtime with every request. Finally, the focus of this talk, reusable agents and tools. This is a comprehensive kit of starter code, out-of-the-box integrations for memory, orchestration, LLM swapping, and reference implementations to streamline the app development for agentic applications. So my team works on GenOS, and we are a central team that generally works on customer-facing problems, R&D applications for building new products. But early on in GenAI, we shifted our focus to making our customers Intuit developers. And it's not common to have an R&D team focus on internal capabilities, but this was a critical time to really make sure our platform was healthy and built for the future. So what was the motivation for our team focusing centrally on building for Intuit developers? Well, I mentioned the rapid expansion into GenAI through Intuit. We have 5 different products, product categories. We have a lot of different internal platforms. There's thousands of engineers, and they're all rapidly shifting to GenAI. Some of them might be new to GenAI. And so having showcase reference examples of working agents is really valuable for helping these teams get started. When I'm building a new application, my favorite thing to do is to go on the internet, find some working code, and tweak it so it works for my problem. And we want Intuit developers to be able to follow that pattern instead of building from scratch. We also want built-in integration with GenOS and other platform capabilities like our customer data platform. We don't want each individual team building the same boilerplate code over and over again for how do I get my customer data for this. We want to have built-in tools that agents can use and that other teams can use to connect these other capabilities into our agentic applications. To give an example of these common patterns that we might want to build for developers, I'm going to run through a few examples of questions that people might ask of our products. So let's start with QuickBooks Payroll. A customer might ask, how do I run payroll? So what are the steps we need to do to solve this problem? First, we need to pull their contextual data. What industry are they in? What type of employees do they have? Next, we need to pull content from a knowledge base. And this knowledge base will contain information on how to actually run payroll in the QuickBooks product. We might need to ask the customer some follow-up questions, like, what are you trying to run your payroll for all of your employees, or is this a one-off for one of your employees? We can collect that info from the customer, and then we answer the question with all of this context. Giving another example, still in QuickBooks, but now in accounting automation, we have an AI agent which can balance your books for you. So the customer asks, can you balance my books? We'll need to pull the customer's data, find out what industry they're in, other relevant information. We need to pull their accounting data. We need to reconcile transactions. And then we might need to ask some follow-up questions. Hey, this transaction just says Amazon. What is the category for this? After collecting this info, then we can execute the book balancing. Finally, another example from the TurboTax space. Someone might ask, do I qualify for the earned income credit? What do we need to do to solve this problem? We pull contextual data. We pull content from a knowledge base. We might ask some follow-up questions, and then we answer the question in context. You might notice there's a lot of identical steps across these problems. And we don't want each individual team building a solution for each individual step. We want pull content from knowledge base to just be a line of code that they can pull in that already exists. So the stuff in green is all duplicated across use cases. So if you're working on QuickBooks accounting automation, it would be really nice if all you need to build is these 3 gray steps, not the whole thing. And that also helps other teams going forward where they see these reference examples and they can pull this common code in. So that's one of the early motivations for building reusable agents and tools. Really providing reference examples and reducing duplicated code across the platform. Another big motivation for a team working on this space is to enforce best practices. As I mentioned, a lot of the teams that are starting in GenAI are new to the technology, and they might not know all of the best practices, all of the leading open source standards. And so we want these reference examples to contain, hey, LangChain. We want these reference examples to show them the best practices so they learn through these examples and then use this in their applications. And not just in teaching best practices, there's also behaviors we want to enforce, such as evaluation of agents. I'm going to take a second here to dive deep into the problem of evaluation because it's really critical. GenAI is incredible. It's so easy now to build a working POC. You can write in a prompt, hey, do complicated action X, and a model is just going to do it. It's crazy how quickly you can get something that is pretty complex off the bat. Compared to that traditional AI, where your development process is a little slower. You're going to collect some training data, which is going to take time. You're going to train a model, also takes time. You're going to fine-tune your hyperparameters. You're going to see what happened, and then you're going to get more training data, tweak your hyperparameters. It's a little more slow of a process, but it's more linear and predictable. In GenAI, when you see an edge case that your model, that your application currently isn't handling, you probably just add a line to the prompt and say, hey, in this scenario, do this. You might add some content to your knowledge base. And then you keep doing this over and over again. And after you have 15 different edge cases covered in your large prompt, the first edge case you covered might not work anymore. It's not reliable what behaviors your model does or doesn't do, and it's really hard to actually get a holistic understanding of the complete behaviors of your application. So it's really, really, really important to build thorough evaluation sets from the start. Now, let's be honest, that's not so fun. It's way more fun to do prompt engineering and application development. So teams don't necessarily build this in from the start. Having this be a fundamental component of a starter kit is really essential to make sure teams are treating evaluation with the importance that it needs to be. And that's another big, big motivation for our team focusing on reusable agents and tools, evaluation. Before I hand it off to Shradha and to talk about a specific use case, I want to call out some big OSS accelerators. Keeping pace in GenAI would not be possible without open source software. And there's a few projects which we'd like to draw specific attention to. The first is LangChain, LangGraph. I think Harrison and team like to refer to the body of their work as the LangScape. Incredible project, really bringing together the whole GenAI community. The next is LangFuse, which is an open source LLM monitoring platform. For a high governance company like Intuit, having the monitoring production platform be open source is so critical for that getting the approval from our legal and security teams. The next is Light LLM, which makes it really easy to not have to write code to, hey, if Anthropic, these are your request parameters. If OpenAI, these are your request parameters. Light LLM handles all that for you. Deep Eval, fantastic evaluation library. Really, really good for giving you LLM as a judge and other evaluation techniques out of the box. Finally, NumaFlow. Not necessarily a GenAI library, but when you're operating at the scale that Intuit operates on, real-time data and stream processing is really important, and NumaFlow is how we handle that. Wonderful project. To wrap up on the reusable agents and tools high-level introduction, some lessons that we learned in this journey. One, having central teams building examples and reusable tooling helps accelerate individual use cases. It just removes steps that they would need to do otherwise, and it removes duplication across the platform. It also ensures consistency across use cases in a large organization. There's many different teams working on many different things, and without a central team, they might not all solve the same problem in identical ways. The next is it promotes knowledge sharing and reuse. One central team in the middle of it all can say, hey, you and you guys are working on similar things and should talk and maybe build one solution. Finally, it ensures that important but often skipped components, such as evaluation, are addressed from the start and easy for use case teams to implement. So you've heard about the reusable agents and tools framework as a whole. Now you can hear from Shradha from a use case team that leveraged the framework in their work.
Thank you, Conrad. So data capability use cases. So before I talk about the use cases, let's look at the high-level architecture of our data platform. On the left, you see events in different varieties and format, like clickstream events, file events, change data capture. All of these events are sourced, curated, and materialized into our clean data lake. These events are further processed for derivations, enrichment, feature engineering, run ML pipelines, and then persisted back to clean data lake. Our clean data lake is based on open lakehouse architecture. Our batch pipelines are mostly run on Spark. We use Flink for our stream processing pipelines. We support both AWS Stack as well as Databricks. Our engineering pipelines are running on EMR serverless, and our analytical pipelines are running on Databricks. Delta Lake is native to Databricks, so we apply Uniform on top of that to generate Iceberg metadata so that it works well with the rest of the AWS stack. We use S3 as our object store, and Kafka we use as the messaging bus. All of this lakehouse metadata is persisted into what we call as data map registry. And then we have built different experiences on top of that. Data discovery is a platform where you can search for tables, and data exploration is built on data map registry, and we are using DB-SQL. And then you can build data quality and data observability using the rich metadata. Our analytics platform uses Athena for exploration analytics. We also use Databricks. We are using BI tools such as QuickSight and Tableau. And our AI uses Amazon SageMaker Studio, as well as we are also evaluating Databricks. So let's look at Intuit's data landscape. We have 200K plus tables in our data lake. We have petabytes of data. We have 30 years of historical data with a history of acquisitions and migrations, and we serve 100 million customers. So generating data insights typically involves like finding data. And once you have figured out, what is the data, you want to explore data, and then you build pipelines on that. But with our landscape, we have around 200K tables. And even if you run the most sophisticated search or the best and the greatest AI, your search results were not great. In fact, have you guys faced like challenges in your company around this, finding data, understanding? I see some nods. Yeah. So this is a complex problem. And so Intuit started a data mesh strategy a couple of years back. So data mesh is an architectural pattern which is particularly suitable for large organizations dealing with complex data, huge volume data, and companies who are looking to structure the data and derive value out of it. And data product is the core of it. So data product is the smallest unit of architecture that can be independently deployable and has all the required structure like data, metadata such as semantic model, mapping to tables, code, infrastructure, all the necessary information so that it can operate on its own. So the idea behind this is that you start treating data as products, and all of the data products that we built are measured against what we call as clean data maturity standard that has certain specifics on data quality, reliability, availability, make sure that you have stewards, high quality of documentation, and so on. So with all this clean data maturity standard, it makes sure that the data product that you produce are consumable. It also provides a star rating for your data product, like 3-star, 4-star, 5-star, and only data products which have 3 or more are consumable. So with this, we are able to reduce the data swamp of 200K tables to a manageable state. Now, once you find the data, you want to trust that data. So you need to overlay your data products with operational signals, like data profiling information. You need to make sure that you have lineage. You need to make sure that the data product that you are looking at has been consumed by other teams. We have stewards and other information. And once you have figured out, now this is the data that I can trust, and this is fitting my use case, the next step is creating a pipeline. So creating pipeline also has multiple steps that you need to request access. You need to figure out that for use case, whether you need a streaming pipeline or whether you need a batch pipeline. And with help of AI, we can easily automate these steps. So here we are going to look at a video. So this is our data discovery platform. The user would come here, provide their business use case. The business use case is the top 3 recommended action for non-FTO QBO customers to take to prevent churn. And what you see on the screen is that there is no data product that exists for this use case, but the agent is suggesting that you can use these data products, QBO non-FTO churn predictions, QBO company, to derive your data. And on the right, you see the data product, and this data product has been used in these use cases, the other data product which is used in these use cases, and they are being joined by QBO company ID. Once you have verified, that these are my sources, then you can click on the set button, and what you see here is the target data product. So this is the data product name. This is how it is being organized, and these are the attributes, and you see descriptions here, which is generated by AI, the different integer, the types, and the classification. And then you can also look at the query. So all of these data tables map has the mapping to the table. So what you see on this screen is the query, which is producing the data product. And you can run this query on Databricks, and it shows, the sample rows. And once you verify that it looks good, you can set up this new data product. And this query has been actually saved as a materialized view in Databricks. So materialized view gets automatically refreshed when your source data changes. Or you can also have a schedule. So now we have set up a schedule of every minute. So the schedule is set up, we define the project, and then it is generating the starter code. Here at this point, it is checking that, whether my input tables that I am using have the required access. And the code is now ready for production. It is also generating the machine role, which this pipeline will use to run. Then it identifies location, it applies clean data practices, such as, configuring all data quality rules, identifying keywords, and make sure, all the good practices are followed, documentation is good. And then you can review the data product again, and once it looks good, you can push it to production. And now your data product is available in production. So with AI, with the help of GenAI, we were able to create a pipeline. We were able to identify what were my source data products and push it to production. So let's look at the high-level architecture for this. So we have the supervisor agent, which is doing all the central orchestrator. It is handling feedback. Right now, this architecture is concentrating on query generation agent, but you can plug in more agents, and the supervisor agent can take care of the orchestrator. The query generator agent has 3 primary tools: intent tool, table search tool, query generation tool. The other 2 tools are metadata tool is, to get all the metadata from our repository. The git tool is for, creating and merging PRs and so on. So let's look at the knowledge base. So as I said, right, we had applied all these clean data practices, and we brought down the data swamp of 200K tables to a manageable state. But we observed that even after bringing the tables to a manageable state, the semantic search was not great. So we are now organizing our knowledge base by domains. So my previous demo was looking at a QBO use case, and this is a QBO marketing use case that we are currently solving. So we have created knowledge base by domains, and our, let's say, example, QBO marketing, and this particular knowledge base has around 80 tables. So the size of the knowledge base is kind of a trial and error thing. So you don't want your knowledge base to be too big, as well as you don't want it to be too small. So it's kind of, depends upon your use case, what works best. So you can create those knowledge bases accordingly. So the intent tool is the one which identifies, based on my natural language question, which is the domain the business use case belongs to. It is right now both LLM and rules-based. The user can also specify, hey, this is the domain, and this is the use case that I want to produce. So once you have identified the domain, then you run your table search on top of that. So all our semantic model is persisted into Google Vertex, and our search is running on that. And we also provide all complementary information, such as the clean data maturity score, data profiling information, and so on. And this table search tool returns the top 5 tables. And the output of that goes to the query generation tool. So for query generation tool, we additionally maintain a knowledge base of engineering pipelines. We have a golden set of engineering pipelines. These are curated pipelines. And it also has information on what business use case that pipeline is solving. So what we observed is organizing our database, organizing our knowledge base, and then providing this rich set of curated engineering pipelines, which is telling information on what business case it is solving. Our query generation results were quite satisfactory. So let's look at, on the left, you would see a pseudocode for query generation tool. It extends from the GenOS reusable tools and agents framework that Conrad spoke about. You just need to provide, what LLM model that you want to use. You need to provide the prompt template, and you just need to write your business logic. And then GenOS framework takes care of, interacting with LLM, any retries, authentication, has all the boilerplate code. It does check, for checks for prompt injection, such as, making sure your request and response is falling into its governance standards. And whenever we create a GenAI application, we get an experience ID, and you can use that to track cost and performance of your GenAI application. So the best thing is evaluations. What you see here is I just have to write a JSON file. I have to specify input, and then what is my expected output, and the framework takes care of running it. And you can see this evaluation results. We get precision and recall out of the box, and if you want to plug in more metrics, you can plug in. So we looked at query generation agent. Now let's look at query optimization agent. So what you see on the left is an unoptimized query. And this query has been running for 9 hours, and it's running on clickstream table. And we ran our query optimization agent on that, and it was able to do analysis, why this query was running, and it also returned an optimized query and suggested the optimization. So basically, this table is partitioned by year, month, and day. But like this statement that you see here, date truncate function, that was returning date in this format, YYY, MMD. And because of this, it was not really doing partition pruning, but it was reading the entire data. And when we spoke to the user actually wanted to do analysis for the current month. But there was a bug and hard coding, and the query was written like last year. So here, that's why you could see this hard coding, and the query was running for 9 hours. So with our query optimization agent, we were able to bring it down to 24 minutes. And what we pass to the query optimization agent is, the physical plan that we get from Spark and the business use case. So let's look at the architecture. It's more or less similar to, query generation agent. The metadata tool and get tool are the reusable tools. The query optimization agent relies more on the Spark physical plan and unique lineage, so that you can get the metadata, and then you need partition information and all, and then operational metrics. Why my query was running for for so long, and then the run history. So you provide all this context to the LLM, and the result was quite decent. And we were actually able to optimize, top 100 slow-running queries on our platform, and improve performance and reduce on cost. So next steps. So you saw query generation agent, query optimization agent, but we are creating more agents. Like data quality based on the business logic, you can generate data quality rules, operations agents, such as creating on-call support bots, lineage reasoning. So based on the lineage, you can debug your pipelines. And we are also setting up, investing into MCP and setting up MCP servers where you can expose these tools and agents. We are planning to open source the query optimization agent. We may not open source the GenOS part because that's very proprietary to Intuit. But the query optimization agent mostly relies on open source Spark plan. And yeah, that brings us to the end of our talk. Questions?
Thank you.
Thank you. All right.